Hey guys, welcome back to the channel. Go is a low-level language, but it's also a very simple language. And in Go, there is this major concept of readers and writers. And using that concept, you can basically read and write to anything. You can write into HTTP response, for example. You can write into WebSockets. And one of the things that you can do is also reading and writing from the disk, basically to files. In this kind of like introductory video, I'll show you how you can read and write strings and other stuff to the files. So I'll show you how you can write a simple string to a file, open that file again and read it as a string. I'll also show you how you can write different lines into a file. So imagine this is kind of like a log of your application that is running. So you write different line entries into that file, how to open up that file again, read them in sequence. I'll also show you how you can work with JSON data in Go. So basically you make a data structure and then you want to save that in a JSON file. And finally, which is going to be the most advanced thing that we discussed today, is basically how you can do the same thing when you're writing lines into the file, but doing that for multiple goroutines. So imagine that you have microservices, or whatever they might be, you have all these different goroutines, and they are smashing the main goroutine or like trying to add different things into the file in the same time, and you want to do that and handle it properly. So yeah, that's what we'll be going through today. It's just an introduction to handling files in Go in general. Now, before we jump in, if you are enjoying this video, don't forget to subscribe, like, and if you really are keen to go through the full code, take a look at the snippets and everything, you can definitely follow through with the blog post that I'm going to post in the description below. If you're keen to get the access to the code, you can also do that from the post. Let's get started. All right, so let's start with the most basic example of simply saving a very simple string into the file. So what we want to do is create a file and then save a string into that file. So let's see how we can do that in the most simple way in Go. Now, because I'm going to do a lot of things in this main.go file, I'm going to just make a function for everything that we do separately. So the first thing we need to do here is basically save. So just call this function save string to file. Now, in this function, what I will do is basically the first thing we need to do is basically create that file. For this, I'm going to use a function from the module called OS, and this is called create. So this create function is basically going to create that file, and it will return to us a type called os.file. Now, this os.file is basically a handler for that file, and it has useful methods on it. We will talk about that in a second, and will also return to us an error if there was an issue creating that file. Now, in this specific video, I'm not going to go through the error handling just to make sure that the code doesn't get bloated. But if you take a look at the blog below, you will see how we can handle error properly, because the proper application code is basically written in that blog post. So feel free to have a look there. But just to make things a bit more cleaner, I'm not going to handle errors while I'm showing you how to write the code. So now let's open up one file. Let's just call that string maybe. Yeah, string.txt. Cool. Now, as I mentioned just now, what you will get back from this is a new file and an error that I'm going to basically ignore for now. Now, as I mentioned as well, this new file has multiple kind of like multiple methods on it. It's a kind of like a special type that we work with. The first thing we have to remember to do is basically close this file. And you want to get into the habit of deferring this close file. So you don't want to leave any connections open to that file, because you can block other application, other services from actually reaching into that file and doing something with it. So make sure that whenever you create a file, you defer closing it. So after you're done working with this file, this will get triggered, which is basically to close this connection with the file. Nice. So now we've created that file, and now we want to write some specific string into the file. Again, with Go, this is the simplest example, and it's a really simple thing to do here. That basically is that new file itself has a write string method on it. And this write string method is basically going to literally just write whatever string that you give it to that writer here. And in this case, the writer is basically the new file, right? And it will return an integer, which is basically the number of bytes that were written, and it will return an error that we're going to ignore in this case. Let's just say this is new content for new file, for example, for new file. There's any string that we can put there. And like I mentioned earlier, what we will get back is the number of bytes written and also an error that we will ignore for brevity. Now, what I will do after this, I'm going to basically just print this, just for this. Yeah, I'm going to print the number of bytes written so you can see what we have done after running this specific method, which is the write string method. So for this, I know that this is an integer, so let's do that. And then I'm just going to say like this number of bytes have been written, have been written to file. And in this case, I'm just going to pass bytes here, which is basically what we need to do. And this is basically the simplest way of creating a file and writing a very basic string into it. Now let's trigger this function and see how it happens. So let me just add it to the main function here. And then what I'll do is I'm going to basically go run main.go. And you'll see here I have like 25 bytes have been written into this file. And if I cat, I think this is called string.txt, you can see here this is the content that we have added into the file itself. Cool. So this is the most basic way of dealing with files in Go. You can create a file using os.create. Make sure that you do close that file when you're done with it. And then you can write string directly into that file using the file itself. The file type itself has a write string method, and you can do that, and it will return to you the number of bytes that I've written. Very simple. But what about opening that file again and then reading whatever is on that file? Let's have a look how we can do that. Okay, so how can we open back that file and read the content of that file? For this, I'm going to create a function, a separate function. In this case, is open file and then read content from it. Basically, like I'm just trying to be very descriptive with the names of the functions here. But in this function, what we want to do is exactly that. We want to open that file that I just created, and I want to read it out. Take that content and then print it, for example. For this, there are multiple ways that you can open and read the content of files in Go. One way is the simple way, which we're going to do now, is basically to read all the content at once. And the OS package will give you a very simple way to do that. But the other way is to basically read the content of that file in buffers, basically in chunks. Think about it like this. If you have one file that is 1 gig big, you don't want to like open it up and load it all of it into the memory, because that would be such a waste. What you want to do instead is read it in chunks, read it in pieces. We will do that in a couple more examples, so I'm not going to do that now, but this is the simplest way to kind of like open and read the file content in one go. And it's safe for us to do this here because we know that this file is really, really small. So what I'll do is from the OS module, I have this function called read file. And again, read file is going to give you the number of a slice of bytes after reading that file. But keep in mind that this function actually does multiple things for you. It will open the file, it will load the content into your variable, and then it will close the file again. So it does multiple things there. So it's kind of like the easy way to do things for us. And what I'm going to do is basically open up that string.txt file. As you just saw, what we come back is the file content here. We get back the file content and an error that I'm going to ignore for the sake of brevity, as I discussed earlier. Yes, cool. So now this file content, remember, this file content is basically a slice of bytes. So I can't really deal with it directly. I want to print this content, and I'm going to do that by using a print. Just print, I think, will be fine. And what I will print here is I'm going to convert that slice of bytes into a string this way. So I'm going to convert that slice of bytes, a byte array basically, into a string because I know that's doable. And then I'm going to print that out right like this. Cool. Now let's run this function and see what happens. So open file and read content. And then if I were to save this and then open up here and run this again, this what happened here is that I opened that file up and then I have printed the content into the terminal. Cool. So now you know how to create a file. You know how to write a simple string into the file. You also know how the best and the easiest way, the simplest way of opening a small file and taking those slice of bytes, of like the byte, whatever information is in that file. And then because you know it's doable that you can convert that to a string, you can convert that to a string and then just print it. And again, this is the simplest and the basic way you can deal with files. Usually things are a little bit more complicated than that. Usually your files cannot be loaded at once, right? So in this case, what we want to simulate now is basically a big file. So let's think about it this way. Imagine that you have a log file that you want to log multiple entries in, and every single log entry has to be in one line. So what we want to do is create a file, a text file, but that file has to have basically multiple entries in separate lines. So I want to write in one line, second line, third line, and so on. So let's do that. And then next, we will look at how you can open up that file and read it line by line. Let's go. All right, so let's have a look at how we can save multiple lines into the file. For this, I'm going to make a function. I'll call this save lines to file here. And then the first thing we need to do in this function, like we did before, is create that file. So I'll know here that I know I have my new file. I have an error that I'm going to ignore as discussed before. And then this is os.create. And then I'm going to create a file called lines.txt. This is a very simple file that I'm going to basically put things in terms of this like line approach that we talked about. Again, don't forget that every time you create a file or open a file, you need to close it. Most probably, if you just create it, basically Go is not going to handle that for you. You have to do it yourself. Unless you use something like create file here, and in that, Go will do everything for you. Cool. So we just created the file. Now we have this file that we just newly created. I want to basically put different lines into that file. So obviously, let's just make a slice of strings that has the content that we want to put in there. So this is going to be very simple. It's basically line 1 here, and then line 2, and then let's just say we have also line 3. Cool. So this is basically an array of strings and it has 3 lines that we want to kind of like put into this file. Now, for the easiest thing to do here is basically we need to loop over this lines array or line slice, right? And this will come back from ranging on the lines. And then what I will do here, what I want to do is basically save each one of those into the file itself. And for this, we have this special kind of like a function here, which is called fprintline, right? And the idea behind fprintline is that it will basically do that. It will just take your whatever writer you give to it, and it's going to write a line into the writer, and then it will return how many bytes it has written. It's basically file print line, right? So it will take the writer, and then that writer can be multiple things, by the way. It can be a writer on an HTTP response. It can be a writer into, I don't know, maybe a WebSocket, whatever it is. In this case, the writer is an IO writer. It's a very simple writer here in this case, which is basically the file that we just made, right? So what I will do is basically I'm going to pass that file, and that will take the writer of that file. And then what do I want to put inside there is basically each one of these lines. And I know what will come back here is the bytes written, and a simple error that I'm going to ignore as well. Now, just in case you want to show you something interesting here, this is quite simple to the write string in the fact that it returns the number of bytes written. So just to show you what happens here, I'm going to kind of like keep track of how many bytes were written over everything. And then what I'll do is every time I write, I'm going to go and total bytes equal plus equal of the bytes, how many bytes that we have written. And then finally, what we need to do is basically just print how many bytes were written in total, like we did before. Bytes written in total, and then for this we need to pass total bytes. Cool. So yeah, that again very simple. We create one file, and then we have this string array of whatever we want to do. Again, this is just a simulation. This can come back from different sources, but let's just assume that we have this kind of like sequence that we want to put into the file. We are ranging over these lines, and then we basically use funct fprintline to add into that writer each line, and then we're counting how many bytes we have written. Cool. Let's delete this one, and then basically just trigger this function here, save lines to file. And if I were to run this, what I will see here, I have written 18 bytes into this file. And then if I were to cat lines with txt, I can see here line 1, and there's a line break, line 2, line break, and then line 3. And then that's the end of the file. Awesome. So now we know how we can write a little bit more complicated example. Instead of just writing a string into the file, we can write one line and then a second line and then a third line. Now, what's even more interesting than this, obviously, is reading that file. Now, remember when I said earlier, there are multiple ways you can read the file in Go. You can read the file in its entirety, or you can read it in this buffered fashion, right? And this buffer fashion is extremely useful because a lot of times the files that you work with are too big. So let's have a look on how we can open that file, read it, but read it one line at a time. Let's go. All right, so let's have a look on how we can do that. Basically, open that file and read it line by line. For this, I'm going to create a function. I'm going to call this read file line by line. I am the most boring person in the world right now. And then in that function, the first thing we need to do is basically open that file. Now we have done this before, so let's do it again. What we will do is basically we will use os.open, os.open, and I know that the file is called lines.txt. So I'm opening this file, and that will give me the lines file and an error that I'm going to ignore because I'm an absolute giga chad. Now, again, just don't forget, we need to defer closing that file. So lines file dot close, fantastic. Now I have this file open. Now, remember when I mentioned that we need to read this file in sequence. And to do this, I need some sort of a scanner. Now, there is one whole module in Go to give you this buffered kind of like functionality with IOs, and that is literally called buff.io. So if from the buff.io module, what I will do is I'm going to get a new scanner. And have a look at this. The new scanner will take a reader, cool, and what we'll do, it will basically read from R with a split function, right? So you can give it different split functions, but we want to use the interest, we have an interest in using the default split function, which is basically scanning to lines, right? And this is fantastic. What this will do is that it will basically literally scan your reader, which in this case, the file itself, it will scan the reader, and then it will just scan it with a splitting function that in this case, just lines. So this will basically do exactly what we want. So if I pass the lines file here, what this is basically now is basically the file scanner. So this will, maybe a line scanner. Yeah, let's just call this a line scanner, right? So it's basically, it's scanning each line directly. And then the way you use this is basically every time you call line scanner.scan, it's going to basically scan and advance to the next part, right? So every single time I call .scan on it, it will scan until until the splitting function, and then it will give you the value of whatever is inside there in the text method here, right? So what this does is basically advances the scanner until it meets the splitting function, and then it will give you the value, whatever it has found, while advancing into this text method. Cool. So what we can do here is I can basically say that this is the line content here, which is basically going to be the text here, right? And then what I will do is I'm going to basically print it. So let's just print that. So font print, basically line content right there, line content right there. And just to make sure things a little bit more clearer, what we can do, actually, let's just change this to print line here. Yep, beautiful. Sorry, 1 second there. Yep, this is print line. And then what we can do is also print line, let's just say one line red, and then with a separator here like that. Cool. Now, you want to ask how we can actually deal with errors when you're using this scanner. You can actually do that by scanner itself. So the line scanner will give you an error. So if the line scanner will give you an error like this, and this error method will give you the error if it exists, right? So what I'll do here, I'm going to basically write an if statement. If scanner error equals this, okay, and then if that scanner error does not equal nil, what I'll do is I'm going to basically just handle some errors here. Again, I mentioned that we don't really handle errors while I'm writing this code, but I just want to show you how this is a little bit different when it comes to handling the errors with the scanners here. So error happened during scan. Awesome. So that's basically what we expect here is to open that file, read the content, print each line right away. So let's trigger this function here, read file line by line, and let's have a look. Let's just clear this up, and then just do this. And what I can see here is basically we open the file, we printed line 1, 1 line red, line 2, 1 line red, and then line 3, and again 1 line red. And this is basically a very simple example on how you can read a file line by line. Awesome. So now you know how to write a simple string into the file, read that string again from the file in a very simple fashion. And then you also know how to write lines into the file. And then most importantly, how to read that file back in a buffered fashion to read one line from the file in sequence. Now, let's have a look on how you can deal with JSON data. In Go, you can deal with JSON data, you can deal with YAMLs, you can deal with other types of file extensions as much as you want, really. It's quite simple. I'm just going to show you a lot of things. In this case, I'm just going to show you the JSON data. That's an example of dealing with something else than the TXT files we have been dealing with for a while now. Let's do that. All right. So now, when it comes to dealing with JSON data, first of all, you need some structure to hold your data. So actually, you know what? I'm just gonna deal with. I'm not gonna make like I'm gonna make a function first of all. Let's just say create and save JSON. Cool. Now, inside this function, I need to make some sort of a data structure. For this, I obviously need a type. So let's put that outside of the function, really. It doesn't need to be inside the function. So let's just say type user here, which is going to be a struct. And this will have a first name, which is a string, and then a last name, which is also a string. This is very straightforward, right? And what I'll do here is I'm going to say I have one simple user, which is going to be using the user structures now. And then the first name, the first name here is going to be Jacques. And then the last name here, oops, and then last name, yep, and last name is going to be Doe. Cool. So that means I have this very simple user with which is basically a structure that I want to save into my JSON. Now, right now, this basic structure here is saved in the memory when this function gets run. And what I want to do is basically encode this data into some kind of data that is JSON data, right? And for this, we can use the JSON module. So what I will do here, I will just import a JSON module, no JSON. Yep, this JSON module. And then this idea is called Marshall. So Marshall is going to basically return the JSON encoding of whatever you pass into it. So I'm going to encode user here in this case. And again, the JSON Marshall is going to give me the bytes. So in this case, let's just call it JSON bytes, right? And it's going to give me an error that I will ignore for the sake of brevity. Now, this JSON bytes is the bytes that I want to write into my JSON file. Let's just create that file right away. Let's just call this JSON file, and again, an error that we will ignore, and then os.create, os.create, let's just say this user.json here right there. Cool. So I've created this file. Make sure to declare closing the file, JSON file. Nope, no, we're not going to seek today. We are going to close this file. Awesome. Right. So we have this file right now, and we have my bytes. And what I will do is I'm going to basically write into that file here. And remember, earlier we used the write string method, which will take a string right away. But in this case, I'm actually using the write method, which will take a byte slice to write it right away into that specific file. So for this, what I will do is I'm going to basically write that JSON bytes right there, and that will give me the number of bytes written, and it will give me an error as usual. And then just to show you this, I'm going to, again, like before, I'm going to print the number of the number of bytes that we have written. Bytes written to JSON file. Awesome. Yes, I haven't passed that on. Let's do that. Bytes. Awesome. Let's have a look on what will happen now. So I think this is called create and save JSON. Cool, just a very simple hiccup. But basically, when I run this again, what happens is that I can see this. I have written 37 bytes written into the JSON file. Let's open up this file here. Let's cat it. And then you can see I have first name here, first name, Jack, and then last name equal to. Now, one small tip I want to show you as well is that basically you can see here that we are following whatever the structure that we have here inside of basically our struct, right? So it's using the property name here, and then it's saving that property name into the JSON. Now, this might not always be what you want, and for this you can use this Go tags for the struct to tell it that when you save this into a JSON, use this first name syntax instead. So let's do that also for last name. So again, when you use this into a JSON, use last name instead. Now, if I were to run this again, now again, the same thing. But if I were to cat it, you can see here it's using first name and then last name. So this is kind of like a trick on how you can work with JSONs with template tagging in Go. Awesome. So now we know how to work with JSONs as well. So you can work with a text file, which is a basic string, and you can work with JSONs as well. Now, the next thing I want to show you here is a little bit more advanced, but I think it's very important for you to kind of like put all these ideas into your head. And what we want to do is basically imagine that we have multiple services or multiple Go routines or multiple sources that are trying to literally smash some data into a file. And we want to use Go concurrency to handle this in a graceful way. So we want to make sure that every time we get some data from whatever that source is, in this case, it's going to be a simulated Go routine, we want to save that into as a line into that file, and then move forward to get one more data and save it into a line. Imagine you can have like multiple microservices and they are all sending their logs into one service to aggregate all these logs, and you want to put them in the sequence they have arrived in. Cool. So let's have a look on how we can do that. Now, as I mentioned, this is a little bit more advanced, so I actually want to kind of like structure our mind on what we are going to write in the code before we go out there and write it. Now, what we will have is basically we have this main Go routine that we are going to work with. And in this main Go routine, what we mainly going to do is we're going to start multiple things. We're going to start the 100 Go routines to simulate 100 other functions smashing into our file. And we're also going to start another Go routine. We have the everything, but mainly this main function or this main function that we're going to write in is basically the function here is going to be listening to stuff happening and then action this stuff. Now, we are going to need two channels. One is going to be the data channel where all these different kind of like producer Go routines are going to send the data into it. We're also going to need one more channel. In this case, it's called the done channel. Now, imagine what we have here is basically all these different kind of Go routines. They will be sending all this data into the data channel. And when they are done, somebody is going to be sending a signal to the main Go routine saying, hey, by the way, we are all done. Now for this, I'm going to, again, mock producers, which is basically in this case is going to be 100 Go routines that we will have. And they are also going to be sending this data into the data channel. So that's the first thing you're going to do. So we imagine, again, this is we're simulating many Go routines that are sending data into the data channel. And then I will have one separate Go routine. I'm calling this the conductor. What this Go routine is going to do is basically is going to wait for these producers to be done, is going to keep an eye on them using something called wait group, is going to wait for them to be done. And when they are done, it's going to send the done signal into the channel to tell the main Go routine, hey, by the way, we are finished. So that's basically the main structure we're going to do. So I just wanted to show you this so you can kind of like structure your mind as you're writing the code together. So now let's go back to the code. All right, so let's have a look on how we can do that in Go. Now, for this one example, I'm actually going to use the main function here because this is kind of like the main example I want to show you from this video, really. All right, so remember what I said earlier? We need two channels and one wait group. So we need one data channel, and this is going to be equal make, and I'm actually going to send a channel. I'm going to send just some simple integers in this case. And then I also need a done channel, and this channel is going to be a Boolean, a chan of bool. That's right. And then finally, I need basically a wait group, so var wg, and in this case, it's coming from the sync module dot wait group. Cool. So now I have kind of the setup that I want to do. Now, the second thing I want to do here is basically make a file for me to write things into. So let's just call this the log file, just to kind of like show you what I mean by this whole example. And again, this is very simple at this point, os.create. Let's call this log.txt, happy days, and then make sure to close this file when I'm done. So I'm going to declare this statement. Awesome, nice. Now, what I want to do here is basically make mock producers. So I mentioned earlier, we want to have 100 different producers. So I is going to start at 0, I is less than 100, and then I plus plus. What I'm going to do in this case, the first thing I need to do is basically add 1. So I'm counting up in this wait group by adding 1 into the wait group. And then I will basically start a Go routine. So go func, like that. Yep. And then inside of this Go routine, what I want to do is basically very simple. I want to do two things. One is I'm going to send a random integers into the data channel. And for this, I'm going to say rand.int in, so a random integer with a maximum value of 200. Once I have done that, I'm just going to say, hey, by the way, the wait group, I'm actually done. I don't have anything else to do. So that's basically it. And this will mock basically the producers that I talked about earlier. So this is basically this part here. So 100 producers are going to send data here. They're not going to do anything complicated. They're going to send a random integers, which is this line here. And once they do that, they're just going to say to the wait group, one of us, like this guy, is actually done. Nice. So that's the first thing we need to do. The second thing is we have this conductor, goroutine that is going to watch over these other goroutines. So this guy is going to conduct everything. It's really fancy and cool. So what I will do is basically wait for everyone to be done. So it's waiting for this wait group to go down to 0. And once that happens, what it will do is basically going to send a signal of true into the done channel, right? And then when that happens, we need to action all those things. And that's what I meant by saying, finally, when you go to the main routine, you're going to listen and action things, right? Now for this listening and actioning stuff, we're going to use a select statement. So for select keyword here, and then I need to have multiple cases here. One is basically if I get any value inside of the data channel, I need to handle that in one way. And then the other case, if I get any value inside of the done channel. Let's take a look at the value first. I already have my log file open. So I have this log file. I have the log file and I've created that. And I want to write into this log file whatever value I get in one specific line. So for this, as I did earlier, I'm going to use fprint line right there. And then I'm going to write into the log file. And what I will write into this log file here is basically the value that I'm getting from the channel. Now, I don't, in this case, I actually don't really care much about how many bytes we have written, but I actually care about the write error because I want to show you how we can handle that nicely. So the write error here is going to come back. And what I want to do here is basically, if I do get a write error, if it doesn't equal nil, what I want to do is I want to actually basically send false, I want to send false into the done channel, right? I want to send false into the done channel. And you'll see in a second why I do that. But I think this is very important for you to understand. If I do have an error from any of the writing that I'm trying to do, I'm going to send a false value into the done channel, meaning I haven't actually done what I wanted to do. I just failed for whatever reason. Cool. That being done, what we can do now is basically handle the signal that we can get when we send that over to the done channel. All right. Now, what I'm going to do here is I'm going to say if signal is true. Now, in this case, that will happen at the end, which remember, basically, this will happen on this line here. If the signal is true, that means the conductor has said, everybody's done, my man. Everything is good. We are all Gucci. And if that's the case, I'm simply just going to say, hey, you know what? I'm actually done here. So I'm going to print line saying, basically, everything's good. Everything's good. All done. Everything's good, all done. And don't forget to return. This is very important for you to close everything because we are now into this for loop. And then returning here will basically tell Go that actually I don't need to do anything else. So and Go automatically will shut down all the channels and it'll close everything. Now, if signal is not true, and this is the case where something bad has happened, then what I will do is I'm going to basically say again, fprint line, something went wrong. In this case, something went wrong. And I'm not going to go into how you can kind of like transfer that error back into the channel and then how you can show it and all that stuff. Basically, I'm just going to say something went wrong and I'm going to return. Awesome. Let's go through this code one more time before we run it. So basically what we have here, we have two channels, one data channel, one done channel, and we have the wait group. We create a file called log.txt, and we make sure that we declare closing the file. We mock producers in this case is basically the number of, let's go up again. We mock producers in this case, which is basically 100 different goroutines that are sending random numbers into the data channel. And once you do that, each one of them is going to call wait group.done. And then finally, one more goroutine to be the conductor is going to wait for all the other goroutines to be done. When they are done, it's going to send through into the done channel. And then mainly what we're going to do into the main goroutine is basically we're going to select and kind of like wait and listen. We listen for values in the data channel. We handle that by printing them into the file. If something goes wrong, I'm going to send false into the done channel, and we listen for values that are coming into the done channel. If we send through there, everything's good. If we send false, then something went wrong. Awesome. So let's have a look at what happens if I were to run this code. Everything's good. I'm done. Cool. And I'm going to cat into the log.txt, and you can see here that we have written 100 values there. If you don't believe me, then let's just open it up right there. And you can see here, we have 100 lines of random numbers. All of them are maximum of 200. And that's it. So this was a slightly more complicated example of having to write different things from different Go routines and saving them all into one place. That's it. So in this video, I've shown you how to write a very simple string value into a file, how to open that file again and consume that string value, or how to consume a file in its entirety. Obviously, along the way, you learn how to create files, how to close files and open them and all that. You also learn how to input data into the file in terms of like lines, and then how to consume them in a buffered fashion, reading them line by line. We also talked about how to work with JSON data in Go. So basically how to make some data structure into JSON bytes and then saving them into a JSON file. And then finally, we talked about something a little bit more advanced, which is that how to handle data coming from multiple or million or whatever it is, multiple Go routines trying to save data into the file in one go. Thank you very much for listening. I hope you've enjoyed the video, and don't forget to check out the blog post down, which is linked down in the description below. In there, I'll go through a little bit more details during the code, and you can also download the code at the end if you want to. Thank you, and I'll see you in the next one. Bye-bye.